Hi everyone and welcome back. I'm here again to the frequency counter restoration, and this is the next module that I want to take care. So the first thing that I want to see if I can repair the joint here, the coupler, and see if we can do it without any further damage. As I have seen in the very first video, this plate is a little bit bent, so hopefully it will be possible to repair it. This dial lamp, it's broken, and I don't even know if I can fix it in some way. I will probably leave like that. This is also meant to be the pilot lamp. So when the power is on, the lamp will glow up. So let's go ahead with the repair attempt and see if we can proceed with the cleaning and the restoration. The first thing that I want to try is to remove this spring, and that seems not really easy. Okay, but actually I've been able to remove it. So I wonder if I can press a little bit and see if I can make them free. Since I don't want to move the position on the shaft, I just want to see if I can force a little bit more here, and maybe I will be able to move. Or maybe by turning this. No way. No way to make him free. It's very tight, and I'm really afraid to break these joints. Okay, now they are free. Oh, the capacitor is very, very tight. Very tight. But at least now they are free. And yeah. So we can proceed with the cleaning. I've just finished to loosen the screws over there. I already have sprayed the potentiometer, since it was clearly dirty. We can see the dust from outside. So let's see the condition of the variable capacitor. That is not really good. Look at that. That is really, really oxidated. And I believe those are adjustable capacitor. So, lot of cleaning here. By the way, look how neat is this coupler here. Look at that. This clearly should move all together. Yeah, it's really tight to turn. Very tight. Okay, I will remove all the tubes and I will wash it with kerosene, and hopefully it will come a bit more clean, and all the more thick oxidation should go away. And before to proceed, I want to see also down here the condition, and well, clearly there are some oxidation signs over there, and also down below there onto the tube sockets, clamps. However, all in all, it's not too bad. And look how neat is that. Look at those beautiful coils over there. Yeah, this is built in a very beautiful way. I love this kind of build, and moreover the metal parts here, it's very thick. It's aluminum, it's almost 2 mm thickness, so it's quite heavy duty instrument. Okay, we can go ahead with the cleaning. To properly clean this sub-chassis, I need to remove the scales, and that is something that I always avoid to do it, but this is not the case. I already have removed the bend indicator scale, and this is the dial. So hopefully there is a notch, so it will be easy to refit. And I now can go ahead with the cleaning. By the way, I already get a bit of cleaning to the variable capacitor, which is really nastily oxidated. And I have also reconnected the spring here in the coupler, and it's quite smooth right now, so hopefully will not affect the functioning. But this we can only see after we will power it on. So still a lot of things to clean. Well, that's the best I can have with the cleaning point of view. So I can start to reassembly and see if we can have some life sign. Well, as ever in this project, I changed my mind, and instead of go directly to power it up with the instrument power supply, I'm going to feed with an external power supply a small amount of DC voltage, since I want to try to reform the capacitors and see if there are any nasty shorts that can prevent the unit to work or may also damage the power supply. So I have connected my Tenma power supply in parallel, so I'm running at 9.2 volts, and yeah, the voltages across the tubes that are out of the circuit, they are climbing, and as you can see, they are still climbing. So they are loading the capacitors. The jumping around, it's because my contact is not good with the lead. So let it work at this lower voltage, and then I will increase. So I will do all the process out of camera, and I'll be back. Well, I'm actually having a very weird behavior here. I'm measuring the voltage at this junction between these two resistors, which are R108 and R109, and they are directly connected to the plus 155 volts. And well, I'm reading this strange voltages, but if I go to directly to the, sorry for the movement, but if I go directly here, I have 20 volts. So something is wrong here. And it's not a matter of contact, clearly. I can scratch here and still have this weird sign. I think must be investigated if there is any broken wire or something like that. Well, that's clearly my fault. This is not 125, but is switched under 155. 155 on pin 6, it just goes on the switches. So I need to move my alligator on pin 10. By the way, this gave me the chance to open it up and clean also down below there. So let's go ahead with the capacitor reforming. Yes, and clearly now I have the right connection, so I have voltages across the tube sockets. Okay, so the capacitor reforming process is finished. No problem so far, but this will be clarified just during the module test. So let's go ahead with the tube testing, close the shields and see if we can have some live sign. All the tubes are fine. Shield is back in place. So at this point must be powered up. But to go ahead with this task, I need to prepare the junction box. So I go to the workshop and try to make something that resemble the original one. Working on the power junction box, the majority of the work is done. The box is done with all the holes that are for binding posts. So what I need to do now is to drill holes to mount the plate in place and bend those two flaps in order to receive this and be mounted on. Drill holes and so forth. And the way that I'm going to do to have the connections, the electrical connections, is to use those cinch terminal strips, and that should work. So let's go ahead and finish this one. Well, let's see if the rule measure twice and cut one. Yeah, perfect. So I can proceed with the bending. Also, the binding process is finished. It's almost okay. Now it should fit and stay below, and when the binding posts are in place, they will flush this. I gave the maximum room available since we need a lot of space inside, because there are a bunch of connections that they will require room. So hopefully everything will be fine. And while I was here in the workshop, I have also cleaned this capacitor that belonged to the Radio Compass ARN7 that was in need to be restuffed. Unfortunately, while I was cutting the top, the late shock has cracked in 3 points and very badly. So I have managed to straighten it as much as I could, and should be good enough to go ahead, so I can also complete that project finally. So let's go ahead with the drilling, but to proceed on that, I need to grab the original manual and see how the original junction box was arranged, the wiring harness output arrangement. And this is how it ended up. Not too bad. Clearly, as I will show you later, that it's resembling the original one, but clearly is not identical. And I have machined this small tool in order to be able to tight this binding post bolt here. It's a sort of round bolt. So let me assemble everything and see how it looks like. This is the junction box finished from the mechanical point of view, and clearly must be wired up. This is the way that I will do. So I will make this 3 wires harness, but later I will try to wrap, make like aeronautical style, actually like the original one, with this wire wrap solid wire. I am not quite sure that I will be able, I mean, this, if it's really suitable for that purpose, but hopefully it will. So meanwhile, I also have received something that I was waiting for this project, and indeed it's the 1.25 meg crystal. So at this point I can clearly close the overnighted crystal oscillator device and proceed to the project. But I think this will be done out of camera, especially the wiring harness process. It's quite boring, so I will prepare it off camera. So in the next episode of this project, we will have this finished up, this wired up, so we can proceed with the test of this sub-chassis, the complete test of the crystal oscillator with its own overnighted crystal oscillator, and we will go from there. Hopefully, actually after this will remain only one sub-chassis to be checked, and then we can reassemble everything and make an overall test. So thank you very much for watching, and I'll be back soon.